Hello and welcome back. Today we are going to look at Python sets. Now, a set is a collection of unique elements which is unordered, unchangeable, and indexed, and do not allow duplicate values. Now, Python has built-in implementation of the sets and its operation functions. A Python set is one of 4 built-in data types. The other 3 data types are list, tuple, and dictionary. The features and manipulations of sets are based on the set theory. Elements of a set are unordered. A set cannot contain duplicate elements. There are 3 basic operations on a set, that is union, intersection, and complement. Now let's look at Python set creation. Set items can be of any data type and contain different data types within the set, that is, or a string or an integer. We can create a set using the curly brackets, or we can use the set constructor to create a set. Now let's create a set using the curly brackets. Now this is a set, and as you can see, it has contained different data types. We have a boolean, value of false. We have a string of 3. We have an integer of 2. We have a boolean of true value. We have a string of 1. You can check the type of a set with the type function. As you can see, it's of class set. Now let's create a set using the set constructor. We use the set constructor to create set example 2, which is this one now. It contains the different values, different data values: true, which is a boolean; mango, which is a string; 6, which is an int; and 8. Maybe we can say we can put a float here. (8.2) This is a float. This is a boolean value. This is a string. And this is an int. And as you can see, as we added, the sets are unordered, so the way you put the items in is not the way you get the items out. As you can see, it's not the order that it has come out. 8.2, it has started from behind. Then it gave me the boolean, which is now the 3rd value. Mango, which is the 1st value, has come to the 3rd value. Now set is unordered. Let's look at accessing set items. Set are unindexed. You cannot access items in a set by referring to an index or key. Access set items by a for loop, or check if a specified value is present in a set by using the in keyword. You cannot use an index, unlike lists or tuples, where you can index. This is index 0 in a list, index 1, index 2 in a list. Sets are unindexed, so you cannot use index numbers to access the set items. Instead, you can loop through the set to get the items, or check if an item is inside a set with the in keyword. Now let's access a set item. Let's access this set E2 item using the for loop. Now this is how we've accessed these items of set E2. These items, we've accessed them using the for loop, and we've print one by one on the screen, which is here. Now we can check if an element is present in a set by using the in keyword. I've used the in keyword to check if mango is in this set. The element, the value mango is in the element, and as you can see, we have mango here, and I've used this in keyword to check, and I've gotten a Boolean value of true. Now if I say potato, or potato, I get a false Boolean value, which means potato is not there. Let me return to mango. True value. Well, can you change values of a set? Once a set is created, you cannot change its items, but you can add new items because sets are immutable, but you can add the items. You cannot change this value from 8.2 to 8.3. You cannot change this value. True or mango, that's what we mean by immutable, but you can add items to a set. You can continue adding items to a set. How do I achieve this? We use the add method to add items to a set. Now this is a set. This is my set with the lettuce, spinach, silver beet, and I want to add cabbage, the vegetable cabbage, onto this set using the add method. So this is how I'm going to do it. Now as you can see, I've add cabbage, which is here. Now remember, set is unordered, so the order you put in the set is not the order that you'll get out the set. So we have silver beet, lettuce, cabbage, and spinach. Well, what if you want to add another value from another set? This is what you're going to do. You can add items from another set into the current set using the update method. Now we have a set, two sets here. We have set E4, set E5 with the values in them. But now we want to add elements from set E5 into set E4. Now I want to add E5 into E4. To achieve this, we are going to use the update method. Now, as you can see, the items of E5 have been put into E4. We have cucumber. Remember, sets are unordered, so we have cucumber, pumpkin, potato. Potato is here from E5. Here's potato. We have yam, which is here, and we have sweet potato, which is here. You can still add an iterable like a tuple, list, or dictionary into a set, still using the update method. Like now I have two sets here. I have set example 6 and a list which is an iterable. An iterable is something you can loop through. Now I have set E6 and a list. So I can add the elements of a list to set E3, and to achieve this I'm going to use the update method. Now, as you can see, the items of this iterable, which is a list, have been included in set E3 using the update method. And since set is unordered, you can see we have plums, then peaches, then nectarines, then limes, which is here, grapefruits here, mandarins here, oranges here, apricot. You can see apricot, it's here, which is here. So sets are unordered. So when you add anything into a set, it's going to make, when you print it on the screen, it's going to mix it up. It's not like list, where list, when I put this thing here, the order I've put in a list is the order I'll get it out in a list. Let me give an example here. Now this is ordered. Lists are data types which are ordered, but sets are not ordered. So you can see nectarines, apricots, peaches, plums. You can remove items from a set using the remove method or the discard method. We like to remove mandarins from this set E6. So we want to remove mandarins from set E6. This is how you're going to do it. Now, as you can see from this set, we do not have mandarins. We've used the remove method to remove the mandarins. We can use the remove method. Let's say remove nectarines. Now this is nectarines, so we're going to remove from set E6 this value. Using the discard, sorry. As you can see, from set E6 we don't have nectarines. You can remove a random item using the pop method. The return value of the pop method is the removed item. Sets are unordered, so when using the pop method, you do not know which item that gets removed. Now this is my set, another set with the list of fruits. Now I'm going to use the pop method to remove a random item, and I'm going to save it into a variable called b, because the pop method returns a value, and that value is what will show you what has been removed. Now, I've used pop method to remove a random item to set E7. Now I've saved that, because pop returns a value, I've saved that value into this variable b. Now I've print b to show me what value has been removed, and it has shown me kiwi fruit, which kiwi is here. But when I print set E7, I've seen its confirmation that kiwi has been removed from this set. And you can use the clear method to clear the set. Now if I want to clear as you can see, I have an empty set because I've used the clear method to clear. I've used the clear method to clear set E7. I don't have any values inside. To delete a set, you use the delete keyword. Now, as you can see, I've used the delete keyword to delete set E7. Now, when I print set E7, I'll get an error. Name set E7 is not defined because I've already deleted that set E7. Now let's look at set operations. Set operations are the operations that are applied on two or more sets to develop a relationship between them. There are four main kinds of set operations. We have union of sets, we have intersections of sets, we have complement of a set, difference between sets, that's a relative complement. So you're going to look at it and you're going to use Venn diagrams. We're going to use Venn diagrams to understand the operations on a set. Now, a Venn diagram is a logical diagram that shows the possible relationship between different finite sets. The first set operation you're going to look at is union of sets. Now, for a given set A and B, read as A union B, is the set of distinct elements that belongs to set A and B or both. This is set A, this is set B, or both. The union of sets is the set of all elements. This is all the elements of both the sets without duplicates. Now, the sets without duplicates. In Python, we can use the union method. We use the union method. The syntax is vertical bar, or the update method to join two or more Python sets. The union method and the vertical bar operator returns a new set with all items from both sets. Now, the update method inserts the items in set 2 into set 1. It does not return a new union but changes context of set 1. Now, we're going to look at each of these methods, the union and the update, to do the first set operation of union of sets. Now I have these two sets, A1 and B1. The union method returns a new set with all items from both sets, no duplicates. Now we have A1 with 1, 2, 3, and B1 with 3, 4, 5. Now, if I do a union of this, I'll have all these sets with no duplicates. All these sets as one with no duplicates. As you can see, I've done a union of these sets. The values that are in this union, because now union returns a new value. With this new value, we saved it under union 1 variable. So we have the values of the two sets, but without the duplicates. Now we can use the union syntax. I've achieved the same result with the union syntax, which is a vertical bar. Now this is a set of A1 and B1, but without the duplicates. I can also use the update method. Now let's have a look at it. Now the update method inserts the items in set 2 into set 1. The update method will change one of the original sets. Now the update method will not return another set for me to save it, but it will change the original set, this one. Now this is how I'm going to do it. Now set 1 updates set 2. Now if I print set 1, I've updated set 1 with the values of set 2. Now I have 1, 2, 3, 4, 2, 1, 4. Remember, this a duplicate value, so it's going to be removed. We only have one value. Now 3, we only have 1, 3. Now the second operation is intersection of sets. Now this is the intersection of set A and set B. Now intersection of set, these are the elements that are both in A and B. Now for a two given set A and B, read as intersection A intersection B is the set of common elements that belongs to set A and set B. Now in Python we use the intersection method or the ampersand operator or the intersection update to get the set of common elements in the set to be joined. So the intersection method and the ampersand operator will return a new set that only contains the items that are present in both sets. Now the intersection update method will keep only the items that are present in both sets. It does not return a new set, but changes the existing set. Now this is what you're going to get, the values that are both here. Now if you have like 1, 2, 3, 3, 4, 5, we are going to get only the values that are in both sets. Let me show you with examples. Now I have two sets here. I have A2, B2 with these sets. Use the intersection method to get A2 intersection B2. Return a set that contains the items that exist in both set A2 and B2. Now this, I want to get values that are in both these sets. Like I can see here there's 6 and there's 6 here. So I'll get this value, I'll get this value 7, I'll get this value 8, I'll get this value 9, I'll get this value 10, but not 11 or 12 or 1, 2, 3, 4, 5, because this is what is inside in both sets. And remember, you're going to remove the duplicates. So we're going to use intersection method. As you can see now, the new variable, the new set, has only values that are in both A2 and B2. Like here, only values that are in both A and B. So only values that are in both A2 and B2, which is this one. We can also use the ampersand operator. We've achieved the same results with the ampersand operator. Remember, the ampersand and intersection method, they give you the return a new variable, a new set, not a new variable, a new set, which we can save it into a new variable. We can still use the intersection update method, but this one will change this set. It won't return a value, it will change this set. So use the intersection update to get items present in both sets. These are the two sets. Keep the items that exist in both set 1 and set 2. As you can see, the intersection update has changed the value of this set. Now set 1, when you print set 1 again, when you update these two sets, we get the values that are only in both the 2, but we remove the duplicates. Now we have 1, which is there, and 3, which is there. 2, 4, 5 is not in set 2, and 10, 8, 6 is not in set 1. Now the third set operation, set difference, denoted with this one. Now there's a difference between two sets, A minus B, which means this is the set A, this is set B. So we get sets and then we remove the sets which are also in B. So you only get sets with the values which are in A. We remove in these two sets, this is 1, 2. If B has sets that are also, no elements that are also in A, we remove those sets altogether. Now the difference between set A and B, denoted as A minus B, lists all the elements that are in set A but not in set B. Now in Python you will use the difference method or the minus operator or the difference update method. The difference method and the minus operator returns a set that contains the difference between two sets. The difference update method removes the item that exists in both sets. It does not return a new set but changes the existing set. The difference update method is different from the difference method because the difference method returns a new set without the unwanted items, and the difference update method removes the unwanted items from the original set. Now we're going to look at this, don't worry. Now these are my two sets, A3 and B3. Now I use the set difference method to find A difference B. Now let's have a look at this. I've used the difference method. This one I've used the difference operator. Let me use the difference method. Now I've used the difference method to get the difference, to get the set, return a set that exists in both set A3 and set B3. Now you can see the elements. We have fork, we have sickle, we have, let's see, rec. Rec is in both. The difference method has removed the sets that are in B. Now fork is not in B. Sickle is here in A but is not in B. Horse is in A but is not in B. Mattock is in A but is not in B, and plow is in A and not in B. Remember, the sets are unordered, so the way you put the set in is not the way you will get them out. Now gloves is in B, so we don't see gloves here. Hoe is in B. Wheelbarrow is in B, spade is in B, and rake is in B. Now you see rake has been removed. Rake has been removed, this rake here. Because it's also in B, it has been removed. Mattock. Mattock is in A only, so we have mattock here. Now we can use the operator. This is the easiest way to do it. Or the cleanest way to do it, not easiest, the cleanest way to do it. We get the same result, that is we get a set that has the values only in A, not in B. Now we have the values. The difference method is going to give me the values that are in A and not in B. Now, the next set operation we're going to look at is set symmetric difference operation. Now this is a set symmetric difference denoted with the delta. Now the symmetric difference between two sets A delta B is the set of all the elements that are either in the first set or the second set but not in both. Now if you have a set, these are two sets. Now you get the sets which are here and here but not in the two sets. Now we use the symmetric difference method or the operator to return the elements that are not present in both sets. Now I have my two sets A4 and B4 with the values inside them. Now I'm going to use the symmetric difference to find the method between A delta B. Now return a set that contains all items from both sets except items that are present in both. Now I'm going to return all the sets that are in set A and set B are not items that are in both sets. Items like, let me see what is here. You see like grapes. Grapes is in both sets. So I'm not going to return grapes. I'm going to return only I'm going to return only values that are in set A and values that are in set B only, but not in both sets. Now, as you can see, I've used the symmetric difference method, which returned a new value, which I've saved it under symdiff1 variable. Now you can see pears, avocado, melon, peaches, kiwi, cherries, guava, pineapple, and apples. But we don't have grapes, which are in both. What else don't we have? Bananas. We don't have bananas because bananas is in both. You can see we don't have bananas here. So we don't have grapes and we don't have bananas. A cleaner way is to use the operator. Now this is a cleaner way of using the symmetric difference. Now this is the operator that you're going to use. We've saved it under symdiff2 variable, and these are the values. Let's check the symmetric difference update. Now symmetric difference update method will keep only the elements that are not present in both sets. It does not return a new set but changes the existing set. Now I've used the symmetric difference, which changes this original set. This one. So set1.symmetric difference update. Strawberries, raspberries, blueberries, peaches, that is in set1. When I used update, the sets that are not in this, like the raspberries. Now raspberries, as you can see here, there's no raspberries. Peaches, which are in both sets, you'll find that it's not here also. Let's look at complement of a set. This is the next set operation. Now the complement of set A, denoted as A vertical bar, is a set whose all elements is in the given universal set. This is the universal set, and this is set A. Now all the elements that are in the universal set but are not in set A. Now this is the complement of A. Now this is the complement of a set. Now complement is in the context of one set, the complement of A. Difference is in the context of multiple sets. Now the difference of set A and set B. In simple terms, the universal set is a larger set which contains set A. Therefore, the A complement and difference manipulations are essentially the same. The only difference is complement is in the context of one set, the complement of A, and difference is in the context of multiple sets, the difference of set A and B. Now, the manipulation of the complement set and the difference set is the same. This is the difference set. It's just that this difference is between two sets and complement is between the universal set. We do have other sets operation. They're not common but are useful to understand the relationship between sets. Now Python set issubset method. Now these are other set operations. The issubset method returns true if all items in the set exist in the specified set, otherwise it returns false. Now if all items exist like this B, all items exist in set A, this set A, this set B. Now the B is subset A. Now if I say B is subset A method, or B with using this operator, returns true if B is a subset of A. Let's have a look at it. Now I have A1 and B1 set. Now if I do B is subset A, it will show me if it will return true if all these sets are in B. It will return false if B1 is subset. B1 is not a subset of A because not all elements are in A. But if I say A1 is a subset of B1, it will give me the true value. It returns the true value because these values, all of them are here. I can see them C, D, E. So A1 is a subset, a proper subset of B1. I can use the operator for a cleaner code. It's true. If not all elements are in both, if not all elements in subset A are in subset B, it's going to return false. That's true. Now, if not all items are present sorry, it's A2. Because of this A2, not all items are here, it's going to return false. A2 is subset, sorry, here. Now, what if not all elements are in B2? So we say subset S2, this variable A2 is subset B2, it's going to return false. There it is. Now when you use the operator, there is subset operator. The next operation you're going to look at is issubset operation. The issubset method returns true if all items in the specified set exist in the original set. Otherwise, it returns false. The A is superset B method, or A, this is the operation, superset operation. B operator returns true if the A is a superset of B. This is an example. Now I have these two sets. Now I have lettuce, spinach, and silver beet. Is this a superset of this? Well, let's see. Yeah, that's true. A3 is a superset of B3. Now this is the full set itself, and this B3 set is inside this A3, because you can see there's lettuce, which is here, there's spinach, which is here, and there's silver beet, which is here. With the operator, this is how you're going to do it. A3, superset B3, you get the value true. The third one you're going to look is disjoint method. The isdisjoint method returns true if none of the items are present in both sets. Otherwise, it returns false. If there's a common element between sets A and B, it's going to return true. Now I have two sets with elements. Now return true if no items in set A5 is present in set B5. Now I'm going to use the isdisjoint method. Yeah, true. This is true. No elements that are in F5 are also present in set B5. You're going to look at frozen sets. Now, frozen sets are immutable sets. Sometimes we need to use an immutable version of a set. E.g., if you want to use a frozen set as key in dictionary or elements of other sets. The frozen set function returns an unchangeable frozen object, which is like a set object, only unchangeable. Now let's have a look at this dictionary. Now this is a dictionary with Argentina. This is a key value pair. I know you might confuse these brackets and think this is a set, but we can see that these are key pair values, which is a dictionary. The dictionary, key value pair. And for a set, do you have a set here? You can see a set, these are just values. If you can see blueberries, plums, these are values. But with the dictionary, key value pair, key value pair, key value pair, and key value pair. Now these are World Cup semi-final results. Argentina with the goal 3 up to Morocco in the semi-finals. Now if I want to get the keys of this dictionary as a frozen set, this is how I'm going to do it. Now I have a frozen set which you cannot change anything. It's unchangeable. But now from this frozen set, I have these keys, these dictionary keys, like Argentina, France, I have Morocco, and I have Croatia. Remember, a set is unordered, so the way Argentina, the way the keys have come is different. It has mixed the keys. So we have this key Argentina, we have this key Croatia, we have this key France, and we have this key Morocco. Now you can use Python sets to remove duplicate values. From a list, you can use Python sets to remove duplicate values from a list. This is my list, and you know list has duplicate. You can put list can contain duplicate values and different values. Now we can use a set to remove duplicate values. Like here in a list we have nectarines, we have apricots, we have peaches, we have plums, we have apricots again, and we have nectarines again. So we have duplicates. And you know, lists are ordered and they contain, the way you put the values in is the way you get the values out. But now if I want to remove the duplicates here, I can actually use a Python set to remove. So how to remove it is just change the list into a set. Now I've gotten a set. If I say print this type of set, I've gotten a class set, and the list I've changed it to a set using the set constructor and save it onto a variable set2. When I print that set2, I have plums, apricot, peaches, and nectarines. Now these ones, I've removed the duplicates from this list. Now if I want to change this set back to a list, I'll use the list constructor. Now as you can see now, I've removed the duplicates from this list using the set constructor. That's all for today, folks. Thank you for joining this session. Thank you for listening up to the end. Now you can click the like button and subscribe button. This will go a long way to help my channel. And may you have a lovely day and may you be blessed. See you in the next video.